Harvard did a study and they concluded that the incoming value of open source into enterprises is worth 450 billion a year. The incoming value is 450 billion. Outgoing value, once it's all put in application, so on, 1.4 trillion.
Welcome back to another episode of Discovering Disruptions in Tech. I'm your host, Howard Holton, and I'm here with Javed Hasan from Lineage. Welcome, Javed.
Thank you. Great being here.
Great. Well, tell us a little bit about yourself before we get started.
So I'm the co-founder and CEO of Lineage, which is a software supply chain security company. We define ourselves as a full life cycle software supply chain security play, which means that we basically go one end of managing your supply chain to essentially updating your software to actually automatically fixing it.
Awesome,
Right.
awesome. So let's talk a little bit about software supply chain, right? It's a term that gets thrown around a lot. I'm not sure it's a term that is well defined in everyone's mind, right? So when we think about why is software supply chain such a big deal, what is kind of the history that brought us here, that sort of stuff.
So let's talk a little bit about it, because I think everyone defines it a little bit differently. That there's no standardization in that definition. If you go look at a car company, they build cars, but they have a supply chain that provides them the parts. And they define the exact dimensions, the exact details about every part. And sometimes the company they buy it from also buys some components from someone else.
Sure.
Right? And you sort of go down, this is why it's called a chain, supply chain, that you have n number of companies tied together to deliver a product.
Right, all the way back to the people that make the raw sheet metal necessary to stamp the part, or the silicon necessary to produce the boards, or right. I'm a big car nerd, so I could go cars forever. But but literally the plastic sheathing on the electric wiring used. Mercedes switched to some that was corn-based years ago, and it literally disintegrated in the cars.
See, exactly. So you nailed it, right? So exactly knowing how something is built and specifying it at every step that it meets the requirements of the final customer is important.
Right.
Now, so if you sort of step back and look at it, every vertical manages their supply chain, except for one.
Sure.
Right, which is the software industry. So we let engineers pick specific parts. So in a car company, you would not let every engineer pick a component from their favorite local garage. You would not get the quality you need.
For sure.
Right? So how to build great software? It's very hard to build great software if you don't manage the software supply chain.
It's also impossible to build great software if you don't have a supply chain.
Exactly.
Like, it's impossible to roll your own on everything necessary to build the complex software and applications that we have today. Right.
Exactly right. So so modern applications, about 70% of the components come from the supply chain, and 30% are built by your own. So take any normal organization.
For sure.
70% components are coming from outside, 30% being built inside.
Right.
Right. And those 70% of components can go about 60 levels deep in terms of that you picked a component A, they picked a component A1, who picked a component A11, and so on till A1111 60 times. Right. That's your depth of a software supply chain that is being assembled at a very fast pace. And now, because we are consuming it in our organizations, and at this moment, the interesting part, or the uninteresting part in some ways, is that it's all opaque, and the risk is unknown.
Sure. Now, correct me if I'm wrong, of course, but it seemed like the big push into software supply chain as an awareness component was Log4j. Seemed like more than anything else, because it's one thing to go, well, I know where I used Log4j. Like, I made the active choice to choose and select Log4j. The surprising part was the number of places where I had no choice in the matter, and Log4j still showed up. And I think that's kind of what changed the conversation for a lot of people was, okay, even if I manage my supply chain, I don't manage the transitive property of supply chain, right? I don't get to pick when someone else is embedded in something that I'm using, and thus, it's not just the suppliers that I select, right? The first order suppliers, but it is all of the suppliers all the way back to the raw materials.
Exactly, right? So, and even now you find organizations that may have not fully fixed their Log4j problem, 3 years plus past. Now, so I think there are two things that actually brought this to fore. One is Log4j, which really is a vulnerability or a weakness in the raw material you brought in.
Sure.
Right? And the other one was SolarWinds, which is an attack, which is a tamper, right? So
sure.
So that, and I think these two illustrate the fundamental problem. That one is that the components have weaknesses that are unknown and undiscovered in some cases and are constantly changing. And the other one is they're being used to attack organizations and through them their customers.
Sure.
Right? So you sort of see this malicious behavior, which is a threat, and you see weaknesses inherently built into it. And now if you sort of think of almost all of it is coming from open source, which is sort of, if you think of the modern software supply chain, is open source. And open source developers are great innovators, which is why you use their stuff. And just like almost all great innovators, they're terrible maintainers.
Sure.
Right? So they don't like keeping it fixed, right? Once I build this one good thing, I move on to do the next big thing.
Well, it's a lot of work to keep it fixed.
And
there's not a lot of payoff.
There's no payoff.
There's no reward whatsoever in keeping it fixed.
Right? So the incentive for fixing it isn't there.
Sure.
And so risk is multiplying.
Sure. Well, I mean, it's a little bit unfair, if we're being honest, right? The incentive is there to fix it, but it's there to, like, the person who created it doesn't have the incentive. The community has the incentive, and that's really supposed to be the beauty of open source, right? The beauty of open source is supposed to be when we, as part of the open source community, adopt something, we also adopt the responsibility to contribute back to the community in some way, and in the aggregate, that way we communicate back makes the software better. It doesn't necessarily hold true all the time, but that's supposed to be the promise of open source.
So, that's been the promise, and let's call it the statements. But if you go look at the data that we have, right? So if you think, like we said, 70% of components are open source, 30% are not in an app, right?
Sure.
But 95% of the risk is coming from open source.
Sure.
Right. So and it's pointing to the fact it's slightly more risky than the software you built inside a company.
Maybe. I'm not necessarily sure I agree with that. It's easy to make a statistic say those things, but also the software that I build inside a company doesn't necessarily carry less risk, but it definitely carries a smaller attack surface. If we'll just stick with Log4j as the example, Log4j is used by 3 million different kind of applications.
Yeah.
If I penetrate Log4j, which is publicly available, publicly testable, I can download it myself, I can do all of the security checks on it I want if I'm an attacker looking for a flaw, all of a sudden that flaw is applicable to 3 million potential applications, right?
You fully nailed it, right? So which is, like, if you separate weaknesses and attacks, it's a great attack surface.
Correct.
Right? It's a publicly available attack surface.
That's all I want to make clear. Like, I want to make clear that open source versus closed source, open source isn't inherently more unsecure, but it is inherently a likely better attack surface.
Exactly. And if it's opaque and let's move away from Log4j. So there was this attack called XZ-utils, right?
Yep,
in Linux, right? And there've been just a sequence of these where upstream in open source you go tamper with something, and if you can do that with the Log4j, it's going to flow into 3 million applications, like you said, and then you can attack hundreds. So the return is much higher if you can go tamper the right open source.
Yeah, for sure.
Right? And the other side of this is, just like any software, the older it gets, the more maintenance it requires.
Yep.
Right? So one of the other data points is, as we've looked at this, that 75% of critical and high vulnerabilities in open source are never fixed. So if you think of Log4j as right now, Log4j got a lot of visibility.
Sure.
Right? So in a month later, you had a lot of fixes and options and so on. But if you step back, so I'll give you sort of two data points, that 75% of critical and high vulnerabilities are never fixed because the developers moved on. And about half of all open source is what we call unmaintained. What that means is that for the last 2 years, there have been no fixes.
Sure.
Right? So because the open source developers moved on, and it sort of goes back to, yes, the community will fix it, and sometimes they do, sometimes they don't. But the community is also pretty dynamic.
Sure. Right? I mean, I would also say, like, half of open source not being maintained isn't actually a problem, right? If you use good policies and standards when selecting your open source, you don't select open source projects that have no maintenance to them. you can see the maintenance.
You can, yes,
right?
exactly.
And so why add that risk? Like most things that get released to open source are expected to, most pieces of software just die.
So let me complicate this for you a little.
Sure.
So we said earlier that the supply chain is 60 levels deep. So and most developers, when they're working open source, are not looking at all the 60 levels.
That's 100%
right?
true.
So they're looking at the direct one.
Correct.
So this one is well maintained, right?
Right.
So this one comes from Apache, is well maintained.
Sure, but they're leveraging a library.
They're leveraging the libraries, right?
Right.
And who are leveraging other libraries? So what happens is now, if 10 levels deep, someone stops maintaining it, and that's highly vulnerable, it's still embedded. In,
For
5
sure.
years later, it's
No,
still
100%,
embedded, right?
right.
So then the problem is, how do you
Right.
go
I'm not
that
trying to.
early,
I'm not trying
right?
to wash the issue.
Yes.
Right. But I do think it's important to I don't want people to be turned off from open source.
No, I
If
think
you
that's
get turned off from open source. It's the wrong message.
It's completely the wrong message.
But you still need systems in place to make the best decision possible. Right. So the first thing I would say is make sure that anything that you select yourself is well maintained. Don't select things that are poorly maintained. Second is leverage a tool set that allows you to inspect beyond what you can easily see yourself.
My stand on this is you should use more open source. It is what's driving a lot of innovation.
For sure.
We are now seeing applications that are actually 99% open source. So if you sort of want to speed up innovation, you have to use open source. So that's one part of it.
Great.
The other positive point is, so like Harvard did a study, and they concluded that the incoming value of open source into enterprises is worth $450 billion a year.
Oh, I buy that.
Okay, and the outbound.
Is this an HBR article?
Yeah.
I love that.
I will share it with you.
That's
right?
great. There are two organizations. Like I work for a research company, right? So generally, we're a little poo-pooey on other research.
Yeah.
There are two organizations whose research I read all the time. I read IBM's research and I read HBR's research.
Yeah. So that's a huge thing, right? So now if you now, the incoming value is 450 billion. The outgoing value, once it's all put in the application, so on, 1.4 trillion.
Yeah, I buy that.
So if you think of the value being created by open source, it's huge, and it's increasing fast because we are using more and more of it.
For sure.
Now, the right answer, at least the way we see it, some of this money, let's call it somewhere around $1 trillion that is being generated between incoming and outgoing, should flow back into open source maintenance,
right,
and support open source maintainers better. But there needs to be money oxygen.
Yeah, for
right?
sure.
So open source without money is a problem.
Yes, I agree.
Right?
I mean, like, it would be an incredibly massive, overwhelming change to open source if 1% of the value generated was fed back into the open source community for maintaining. That would be $10 billion.
So you see, I'm a huge fan of college football. So if you sort of see, I don't know how much you follow it, but one of the things that happened in college football is the athletes actually started getting paid. So there a lot of money flowed into it, something called nil money.
For
right?
sure.
Now you're seeing a much more competitive college football than 4 years ago.
Interesting.
Right?
I was aware that happened, but I don't follow college football.
Yeah, so that's what I'm saying. But what you sort of see an example of the standard of college football, and the colleges that are now winning it are very different, or at least the new colleges that are competitive, because the money actually started playing a role, and people move around for money, right? And money is not always the answer, but having zero money to significant money being flowing back into open source would make it much better. So we have to solve that problem fundamentally.
That's excellent. Well, it's also like there's an equality issue there, right?
Exactly.
Like if someone is making money, then everyone should make money, right? Like it would be unfair for you to have a sales team, anyone that run a company, to have a sales team where if the sales team sells, they don't get paid more money. That's why we pay them in commissions.
Exactly.
Right? It'd be bizarre to do that, and yet there is a bunch of places where we do it. College football was a place. I don't follow college football at all, but I'm a big supporter of the. If somebody's getting paid, the players should be paid.
Yeah, the colleges were making a lot of money. The players were not, right? So it's sort of like the open source guys were not making money,
right?
But the enterprises are making
and
money.
And the league was making a tremendous amount of money.
The league is making a huge amount, exactly. So now what we're seeing, so one more transformation that we're seeing in our industry, starting in Europe, is that there's a question that if you ship software with open source embedded in it, are you liable if something happens, right? So Europe is starting to go down that path where they're saying, look, if you put it in your product and you sell it for money, you better fix it.
Yeah, you should absolutely be liable.
Right. It's sort of the same thing, right? Saying if you, So I sort of see that regulation and compliance, regulations actually play a role where they sort of turn around and say, enterprise, you are making money off it, and hence it's your problem.
Right.
First, right? Otherwise, you don't use it.
Right.
But if you use it and monetize it, then support it or get it. You fix it, and then you fix. Again, as you know, in most open source, fixes would go back into open source and benefit a lot of people. So, getting this push of where is the money generated, either you fund the fixing of it, or you pay someone else to fix it. In which case, you get better open source.
Yeah.
Right. So those kinds of changes are needed. Right. So it's good that EU is going down that path. And I'm sure, even here, there's a big discussion on where's the liability, on all of this, right? And it's sort of a tough thing to say that you want stronger liability law, right? But
at the same time, we need it. Right?
Exactly.
Right? You need to be liable for all of the decisions that you make.
Yeah. Seat belts were not required in cars. Going back to cars for a long time. If there were no regulation requiring seat belts would not have happened.
Correct.
Right? But it was essential for safety.
Yeah, it's actually kind of interesting, right? If Volvo hadn't done what they did with seat belts, then the legislation wouldn't have passed, which also allowed seat belts to be adopted, right? Because they effectively shared their patent at no cost. They gave their patent to the world, right? Which is the only way that can work. Had Volvo not patented and said we want everyone to use it, the very next company could have patented it. And once they patented it, they would have locked everybody out, right? So somebody has to patent it and then do a zero cost license for the patent so that everyone can then use it, which then enables a regulatory body to say this is the right thing to do. It's now open and available for everyone to do, right? Versus there are other things that are tried, like microstamping. Right, where one company holds the patent, they do not release the patent for $0. All of a sudden, the legislation does not work, right? Like you have to have this combination of industry and regulation for this sort of thing to work. And I do think we're at the point where we can say and should say, if you've selected open source and you ship a product that has a flaw, doesn't matter if the flaw is in the open source that you don't own, you selected it and you own the liability for that and the damages for that. That way, the only way to fix it is to feed that back in. And again, a 1% feed would be $10 billion, right? There's a $1 trillion value created, so 1% is $10 billion going back into maintaining. That would fundamentally change these things.
And because of such large numbers, right? This can happen actually.
Right. Well, and it doesn't need to go into like a general fund. It can just go directly back. Like you could literally funnel it directly back into those exact projects that you leverage. Right, allowing those to be fixed, which allows them the trickle down of that to echo for everybody else that's using it, promoting the things that people are using, demoting the things they're not using. Because that's one of the beautiful things about open source is the community decides what's valuable by forking it, by leveraging it, by through the stats we all follow on GitHub.
Yeah, exactly.
Right? How many pulls does it have? Right? We all.
And, the most popular ones and so on. Right? Exactly.
Right.
Now, so you see, one more interesting thing that's happening is, so let's bring AI into the equation a little bit, right? So now, again, a Cornell study, university study, right? Yeah. They just showed that from vulnerability definitions, they can essentially generate exploits for 87% of vulnerabilities.
For sure.
Right? So normally, right, if you right now in open source, you have, let's say, about 500,000 vulnerabilities. About 1,500, 1,600 are exploitable. Now you start suddenly saying that AI can make 87 or 90% of the exploitable. And just by reading the security advisory on the vulnerability, which is published for every vulnerability.
So that's 450,000 exploits.
Yes. Right. Now suddenly this thing, now the more interesting thing, right, that's the danger side of it. But the good side of it is that AI can also help fix so that,
for sure.
Go back into open source. So we are seeing that part also improve pretty dramatically. So the ability to fix open source, and the supply chain, is not just tied to humans going back and doing better maintenance, because maintenance is one of the more easier things for AI to do than innovation. Innovation is hard.
Correct. Innovation is very, very hard for AI to do, but maintenance is actually relatively easy.
Comparatively
easy. Sorry, it's comparatively easy.
Yeah. So we are sort of seeing that movement.
Right.
So there's a lot of positive side also that I think the industry will bring to bear in terms of creating a safer supply chain.
So that's interesting. Let me pose. So we need students to always use something that's 5 years ahead of themselves. right?
Okay.
I think that's a reasonable
that's a
statement to
good
make,
thing,
right? Like it takes
Yeah,
time to get a job. You got to
relevant,
you got to graduate. You got to go through all the classes, right? So right now we need students learning how to effectively vibe code. I hate the term, but it is the term that was selected. So vibe coding, right? It seems like universities teaching students to vibe code would be smart. It seems like universities teaching students to vibe code in a positive way by maintaining some of these open source projects seems like a reasonably good thing to do. Yeah. They seem like they're in the right position to do it. It's an enormous untapped workforce, right? It would also mean you'd be like the student themselves would be a maintainer of that application. They'd be able to publish the changes that were done. They'd be able to publish all of the things. That means they'd also graduate with a portfolio that is in fact valuable and not yet another Minecraft plugin or whatever.
Absolutely. It makes complete sense, right? So I think getting, I think it's a brilliant idea. Your credit.
I mean,
like cheap, I was a grad assistant a long time ago.
Sure.
Right? And cheap grad assistants can do a lot of good work also, right? And so, I think it's a great idea for universities to actually do, more drive more automated fixing. Vibe coding is interesting from two angles. One is it drives productivity much higher. The other thing is it makes everything more opaque.
That is true.
Right? So now, and opaque is not good.
That is correct.
Right? So I think having to fix things or thinking about fixing things makes things transparent because you have to understand it to fix
For
it.
sure. Because you can see the before and after. You can look at the before and after and see that really easily.
So I like
even if you don't necessarily understand it, again, now you get back to more eyes having value. Right? So all of a sudden, now we've got college students and everybody wants to create. Exactly. Every software no one gets into software development for maintenance. Nobody does.
Yes.
And yet, 80% of the job is maintenance.
Yeah.
Like you are not paid to just create. You are paid to build and maintain products. And products have an incredibly long tail. So as a software developer, you're going to spend, 70% of your career, 80%, 90% of your career maintaining products that were created, not even necessarily by you.
And that's the worst part of it. If you are asked to maintain stuff, you didn't write.
Correct.
Right? And if 70% of your components are coming from outside or 80%, which you didn't write, and now you're stuck with maintaining them, that's not the life you wanted.
For sure, right. For sure. But I think it's also like if you're able to add AI to that, which it's good at doing, and you're contributing, then by the time you graduate, you get to see that balance.
Yeah. And exactly. I think vibe coding is great for creation, and then making students fix things, I think is great for understanding.
Yeah.
Right, and then getting the depth they need. So you get both sides of it.
Yeah, I think this is great. So let's bring it back to enterprises.
Okay.
Right. So you're an enterprise. You've listened to the 20-ish, I have no idea how many minutes that we've been going on, but let's just guess it's 20 minutes. We've given people a lot of things. We've talked we've waxed poetical and philosophical a little bit, right? About how we'd like the world to change. But what can you do today as an enterprise to really kind of start to wrap your arms around this and gain control over what you can gain control of?
So I think different enterprises are in different states. However, if you are not managing, you need to first discover what's in your supply chain.
Okay.
You need to know what's in your software. Step one, right? I ran an engineering organization at a large security company. I could not have told you 5 years ago what components we had in our software.
Sure. Okay. So,
right.
so let me make the question even clearer because outside of the first level decisions, as in I decided to fork this package or pull this package from Apache, as an example. So that's a first level decision. I took the pull action. Outside of that, and if the package that I've pulled publishes their full supply chain, it's not really reasonable for me to get the full chain without a tool set.
Exactly.
Right? I need a supply chain management tool in order to actually do this. Right? So what do I look for in a supply chain management tool to help me make these decisions?
So the first tool that you look for is an SBOM manager.
Okay.
The software bill, right? So to know what's inside it, you need a bill of material, just like in every other industry.
Right.
In software, you need a software bill of material. And unluckily for us, no one publishes, open source does not sit and publish their own SBOM. And the other thing is software is changing much faster.
For sure.
Right? So some companies are doing 1 million updates a day. So your SBOMs essentially are changing very quickly, so the volume is high. But fundamentally, you need an SBOM manager to understand what's in your software, what is the inherent risk in it, and what is fixable and what is not. And so as in most cases, you discover what's in your software, and you should be able to do it at scale, and modern SBOM managers can now do it at scale. Right. The second thing then is when the next lock, you started with Log4j, when Log5j comes out, you need, and some of us were part of it. It took us months and months to even find the occurrence of every Log4j, which you mentioned.
Yeah.
Now, if you have an SBOM manager, you can find the next Log5j in 10 seconds everywhere, wherever you are impacted. So there's significant operational benefits of doing that. And then the other last thing that you have to sort of figure out, which is how do I fix it at scale? Well, we're building software much faster. There are more and more components. So how do you fix it, right? And half of it, the decision goes to how do I fix my own code, and the other half is how do I source better,
right?
Which you said is select the right open source. Don't select the risky one. And so you need an open source manager coupled with an SBOM manager. You do those two things and find the right source, you're pretty much set. And the tools are now there to do it.
Oh, that's fantastic. Okay, so this has been fantastic. Yeah. I get the feeling you and I could talk for another hour. But in order to keep this a reasonable amount of time, let's end it here. Where can people find you and where can they learn more?
So find me on LinkedIn, a company called Lineage Inc. Right?
Spell Lineage.
Lineage,
for everyone.
Yeah, Lineaje.
Excellent.
So Lineage, right? And so you find me on LinkedIn, find us on lineage.com, and reach out.
Excellent. Well, this has been another episode of Discovering Disruptions in Tech. Please like, subscribe, follow, share, comment, and we'll see you on our next episode. Thank you. Have a great day.
Thanks.